Okay, ladies and gentlemen, welcome back. In this short video, I'm going to be going over the Density of Pennies Lab. This is a common lab that is done to find the density of pennies uh, pre and post 1982. Okay, so let's get into this. So, the reason we're doing this lab is to show that not all pennies are the same. And so some of these pennies were pre 1982. And so the pre 1982 or before 1982, the government was making pennies where 95% of the pennies was copper, and then you had about 5% zinc. So it was a little bit of zinc in the penny, but by and large, the most of it was copper. But as copper got more expensive and it got to the point where it was more expensive to make the penny than the penny was even worth, which didn't make a whole lot of sense. So they switched over to zinc. So instead of having 5% zinc, the pennies starting at 1982 and beyond now have 97.6% zinc versus 2.4% copper. So there's very little copper in your pennies that are made today, and most of it is zinc. So we're going to be looking at how that affects the density of those pennies. And so what you see here is nowadays in the picture, you have most of it is zinc, and then you have this like little cover or I can't think of the word I want to use, but yeah, it's like a thin coating or cover on the penny that is actual copper. And so you can see here how thin that is. And so what we're going to be doing is we're going to be in this lab, we're going to be measuring the mass and the volume of pennies at before 1982 and after 1982. So, and we're going to compare the differences. So, of course, finding the mass is going to be easy. We're going to use a balance. You just put the pennies on the balance, you get the mass and so on. But what about volume? How are you supposed to get the volume of a penny? Like if it was a square or a rectangle or some uh, regular shaped uh, substance, then we could just measure the sides and multiply and get the volume that way. But for a penny and other irregular shaped items, it's hard to do that. So the best way to do that is to use volume displacement. And this goes back to the legend of Archimedes, who was given a crown by a king, and the emperor or king wanted to know if it was actually made out of gold, or if it was pure gold or not. And so Archimedes was given the task to figure that out. And so one day he was trying to figure it out, and he filled up his bathtub, and he stepped into the bathtub, and he got in and noticed the water overflowed. And then he realized at that point that the volume of his body was the measure of the volume of the water that came out of the tub. And so he, legend has it that he got so excited about the discovery that he ran out of his bathtub completely naked, yelling "Eureka!" um, meaning he figured it out. And so that's what we're going to do. We're going to use volume displacement to figure out the volume of the penny. So what is volume displacement? Well, we'll talk about that in just a moment. But we're going to use a graduated cylinder. And a graduated cylinder has um, markings on the side here. So we have these markings here. And so you'll notice that at the top of the volume here of our water, we're going to fill our graduated cylinder with water, and we're going to measure water levels in your graduated cylinder. So when you do that, you'll notice that the top is of the watermark here is bent up a little bit at the sides, and that's because the water and the glass, the water molecules and the glass are attracting each other, and so the water tends to crawl up the glass a little bit at the sides. And so we don't want to read at the top there. We want to read at the bottom of the meniscus. So it's very important that you have your eyes, your eye at eye level with the meniscus, the bottom of the meniscus. You don't want to have your eyes up here. You don't want to be holding it below your eyes. You don't want to be holding it above your eyes so that your eye is down here with respect to the meniscus, because then that's going to cause what is called parallax. And that means basically that the reading of the line in position to the meniscus is going to look different based upon where your eyes are at. So if your eyes are below, you're going to read a different volume compared to when your eyes are above or right on the meniscus. So we want to have our eyes at eye level. We want that eye level with the bottom of the meniscus. So you're going to read the line where the meniscus is, and then you're going to record your data. Okay, so another thing to keep in mind about the data is that your volumetric flask should be able to read to 2 decimal places depending on the volumetric flask. So make sure that you're recording your data to 2 decimal places. Okay, so each of these lines will be a tenth of a milliliter, right? So if you can read, if your meniscus is between the lines, that means you can estimate one more digit past the tenths place. So these markings are 1/10 of a milliliter. So that way, when you estimate between, you can estimate to the hundredths. You can estimate one place more. So that's 2 decimal places. Okay, so so make sure you do that as well. All right, so water displacement. I talked about this before. We're going to measure our pennies. We're going to measure the volume by water displacement. And what does that mean? Well, you're going to start with a certain volume in your graduated cylinder. So that's the picture on the right. So the picture on the left. So let's assume here that we have 10 milliliters of water. So this is going to be 10 milliliters of water. And then what we're going to do is we're going to then put our object, our pennies, into the water. And then what's going to happen is, because the pennies take up space, that's going to cause the volume level of the water to go up, because the volume is being taken up by the extra pennies or extra substance you put in there. So pretend that these are our pennies. We put the pennies in the water. We read the height of the water after putting the pennies in. We read the height of the water before you put the pennies in. And then those volumes, for example, if we started with 10 milliliters without the pennies, and then we put the pennies in, and you have 30 milliliters now reading, the volume reading of the water is now 30 milliliters, then that means that you would subtract the 10, the original volume, from the final volume, and then the difference is going to be the volume of your object. So in this case, the volume of this particular object is 20 milliliters. And so that's what you're going to do with the pennies. I hope that makes sense. Okay, so going on. So once you get the volume of the pennies, you're going to have the mass of the pennies, and then you can calculate the density of your pennies, right? And then what you're going to do is you'll have your value. You're going to find the percent error. So you're going to calculate the percent error of your measurement, which is the density. So what you got to do is you got to have an accepted value. You have to know what the correct value is so you can compare that to your value. And the correct value is what we call the accepted value. That's going to be the value you look up in a book somewhere, or you look up in a standards book with different known values or accepted values for different things, and so densities are one of them. So I'll give you the accepted value, and then you're going to take your value and subtract it from the accepted value. And notice again that you also, in this equation, you have these straight lines on either side. That, remember, is your absolute value marker, right? So anything within here, you take the absolute value of. And all that means is that no matter what value you get, negative or positive, you're going to make it positive. So if you subtract your value from the accepted value and you have a positive answer, then you're just going to leave it positive. If you subtract these two and you get a negative answer, then you're going to make it positive. So you should never have a negative value ultimately by taking the ultimate value of. And then once you do that, you're going to then divide again by the accepted value, multiply by 100, and then that'll give you your percent error, how far away you were from your accepted value. And then according to your groups, we'll have something on the board. And so we'll have a table on the board, and your group will then write in on the board what you got for your pre-percent error and your post-percent error, because we've got to do it for both, right? So you're going to calculate your percent error for the pre-1982 pennies and your percent error for the post-1982 pennies. And then you're going to write those in the board, and then everyone will have the class data, and then you can answer questions like who got the best percent error, who was closest to the actual value, who was farthest, what are some of the errors that were involved in the measurements, what caused you to be farther, what caused you to be closer. And so we can talk a bit about that in your class. Okay, so I hope that was helpful. That's it for this video. Remember, if you like this video, please like, share, subscribe to my channel. Put comments in the comments section. Ask questions. If you have any questions I can answer, please put them in the comment sections. Thanks for joining me. Have a great day.